Hello, section 2.5, part 2. I'm just going to do a few examples for you of things that will show up on the homework. So first of all, if you have the directions to say to graph two functions and show that they are orthogonal. Orthogonal means that at their point of intersection, their tangent lines are perpendicular. So first we're going to have to graph y squared equals x cubed. So to get y by itself, you're going to take the square root of y squared y squared equals x cubed. And remember, when you take the square root, you have a positive and a negative option. So if you're graphing this on your graphing calculator, you would need to type this in as two different functions. Y equals positive square root of x cubed, and y equals the negative square root of x cubed. So then you graph that one, and then the other one, you're going to have to subtract your 2x squared and then divide by 3 and then take the square root. So you'll have positive and negative square root of the quantity 5 minus 2x squared over 3. Lots of parentheses to enter in there if you're putting those in your graphing calculator. So 4 functions here we're graphing technically. 2 pieces for the first one and 2 pieces for the second one. And then our graph will look like, I'm just going to delete this here. Our graph will look like that. So you can see that our places of intersection are here at 1, 1, and here at 1, negative 1. All right? Well, so then we have to figure out if they have perpendicular slopes at those points. So we need to find their tangent lines. Remember, to find a tangent line, you've got to take the derivative so that you can find the slope. So we need the derivative of the square root of x cubed but that would be ugly to take the derivative of, so let's just do implicit differentiation. To take the derivative of y squared here, we're going to have 2y times y prime, or you can write dy dx, and then x cubed is 3x squared. So then you solve that. You get y by itself, y prime by itself, and you have 3x squared over 2y. Divide both sides here by 2y. So that's a lot easier than doing the derivative here. Well, not too bad. That wouldn't be too bad because you would just have 3 over x to the 3 over 2. So that wouldn't be too bad. But over here, then we'd have a lot of mess to deal with. So let's take the derivative of this one implicitly. So the derivative of 2x squared is your 4x, and then the derivative of 3y squared is 6y, and then y prime, remember you take the derivative of the inside function y, and then that equals the derivative of 5, which is 0. A lot of people forget to take the derivative of that 0 there. Then solve that for y prime. So you subtract your 4x and then divide by 6y, and then let's reduce that. So we have negative 2x over 3y. So we've got two different slopes. We've got the slope of the line here, that y squared equals x cubed, and we've got the slope of the line here, which is 2x squared plus 3y squared equals 5. We want we want to show that at their point of intersection, so let's start with this 1, 1, do they have perpendicular slopes? So that's the slope here of this first curve, and if we plug in 1 and negative 1, sorry, we should have plugged in 1 and negative 1, not just, 1 and 1, x is 1 and 1. X is 1 and y is 1. So we plugged in 1 for x and 1 for y, and we get 3 halves. All right, then same thing here. We've got our slope, negative 2x over 3y. Plug in 1 and negative 1. So then we get negative 2/3. Are those perpendicular? Yes, they are. And then I think you can see how to do the same thing with 1 and negative 1. If you plug in 1 for x and negative 1 for y, and then plug in 1 for x and negative 1 for y here, then you'd have the ability to show that these two are perpendicular slopes. Does everybody remember how to tell if two slopes are perpendicular? How did I know that 3 over 2 was perpendicular, a perpendicular slope to negative 2 over 3? Do you remember perpendicular slopes are negative or opposite reciprocals? So you just do the reciprocal of one and make the sign opposite, and that will give you the other slope. And if that relationship holds true, then those two lines are perpendicular. So you don't actually have to find the tangent lines. You just have to show that the two slopes are perpendicular. All right. Another example that'll be on your homework. Find equations for the normal line and the tangent line at the indicated points. X squared plus y squared equals 9. That's the graph. And we're trying to show that at 0, 3, that our normal line and our tangent line, that we can find the normal line and the tangent line at that point. And then also at the point 2 square root of 5. So on the left here, we're going to do the tangent line and the normal line at 0, 3. And over here, we're going to do the tangent line and the normal line at 2 square root of 5. I don't know if people recognize this, but that is the equation of a circle. If you did conic sections in pre-calculus, there is no term with the x. It's not x minus something or x plus something. It's just x squared. So we know that the x value of the origin, or x value of the center of the circle is 0. And this is y minus nothing or y plus nothing. So it's the y value of the center is 0. So the center of this circle is at the origin 0, 0. And remember, this is the radius. 9 is the radius squared. So the radius of this circle would be 3. All right. So first of all, we need to find the derivative of x squared plus y squared equals 9, because we need to find slopes of tangent lines, right? So take your derivative. Derivative of x squared is 2x. Derivative of y squared is 2y, y prime. And that equals 0. Remember, the derivative of 9 is 0. We're doing implicit differentiation here. All right, so then you solve that for y prime, and you get negative 2x over y, and then you simplify that, you get negative x over y. So if we want the tangent line at 0, 3, that's going to be our slope. But we want the slope at 0, 3. So first we want to plug in 0, 3. And we plug in 0 for x and 3 for y, and we get a slope of 0. And then we use the point 0, 3 and the slope of 0 in our equation of a line. Y minus y1, so y minus 3 equals m, that's our slope, times x minus x1, which is 0. So that's the setup, and then you solve it for y and you get y equals 3. So that is the equation of our tangent line. Now, what's a normal line? A normal line is just the line perpendicular at that point. It's not tangent at that point, it's perpendicular to the curve. So if it's perpendicular, and this is the slope of our tangent lines and normal lines are perpendicular to each other, so the slope will be the opposite reciprocal. And I should have not had a negative there. Sorry about that. Let's get rid of that negative. I just did the reciprocal, not the opposite reciprocal. All right, that's still supposed to be an x though. All right, there we go. And then put in, my negative came back. Sorry about that. Scribble out the negative. It didn't matter in this one because of the 0. But anyway, so then that's my slope of the normal line, 3 over 0. What does that mean? It means the slope is undefined. So this function, or this line, this normal line, must be vertical. And it's vertical at this point, x equals 0. So our normal line is x equals 0. All right, sorry about, I keep getting those negative signs back. Okay, those negative signs are not there. I keep erasing them, that's the problem. So that negative sign's not there, that negative sign's not there. Alrighty. So our graph is going to look like this. You graph your circle, and remember, if you want to graph a circle on a calculator, you'd have to solve this equation for y. So subtract your x squared and then take the square root, and you'll have a positive square root and a negative square root. So you have to graph it in 2 pieces. One piece will graph the top part of the circle, one piece will graph the bottom part of the circle. The normal line is x equals 0, so that's this green line here, and the perpendicular, or the tangent line, is 0, or y equals 3, which is this line. So you can see that the tangent line is tangent at the point 0, 3, and the normal line is perpendicular at the point 0, 3. All right, then let's do the tangent line at 2 square root of 5. So again, we have our derivative. We're going to plug in 2 square root of 5. And you plug that in, you get x's, you plug in x for 2 for x and square root of 5 for y, and you get negative 2 over the square root of 5. You don't have to rationalize that, but you can. So if you wanted to multiply by the square root of 5 over the square root of 5 on the top and the bottom, you could. But you don't need to. So now we can write our equation of our line. This is our slope, this is our x1, this is our y1. So y minus y1 equals equals m times x minus x1. Simplifying that, I'm just going to add the square root of 5 over on the other side. I'm not going to multiply it all out. You could distribute it, blah, 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 but there's a lot of chances to make mistakes there. And the fewer places that you have to make mistakes, the better off you are on those free response questions. If you just leave your equation like this, that is a viable equation of a line. Y equals this big long thing, which is just this added over here. So that is our tangent line, and we're going to graph that. And then we want the normal line. So again, we want to do the opposite reciprocal of our slope. Oh, this time I remembered to do the opposite reciprocal. Good, all right. Way to go, Lammers. Then you plug in your points, and you get square root of 5 over 2 for your slope of your normal line. Then you plug in the square root of 5 for y and 2 for x, and then you add your square root of 5 on both sides. So there's your normal line, there's your tangent line, and let's look at the graph. So again, we've got our circle, and here's the point 2 square root of 5, and we have our tangent line, and the normal line you can see is perpendicular. So that's how you do equations for normal and tangent lines at certain points. If you want to find the points at which the graph of the equation has a vertical or horizontal tangent line, we've done this before with horizontal tangent lines. If you remember horizontal tangent lines, you want to find your derivative and make it equal 0. The numerator has to be 0. No matter what's on the denominator, doesn't matter. So when you take the derivative, you're probably going to be doing it implicitly because this is section 2.5, right? Get the y prime by itself, and whatever fraction you have left for your derivative, make sure that the numerator equals 0. So ignore the denominator, just take that numerator at the top and write equals 0 after it, and then solve it. And that will help you find the horizontal tangent line, the slope of the horizontal tangent line. All right, and then the vertical tangent line, you still need the derivative, but remember a vertical tangent line has a slope that's undefined. So then you want your derivative to have a 0 in the denominator. So take that same derivative you had from the horizontal tangent line and set the denominator equal to 0 and solve for x there. And that point will be the point at which the graph of the equation has a vertical or horizontal tangent line. Remember that once you find the x value, you can plug it into the original function to find the y value because you need the whole ordered pair. It says find the point. So you need the ordered pair. All right, another example from your homework, we'll say differentiate with respect to x and then with respect to t. And x and y in that case are functions based on t. So they might be some functions based on time. I'm probably going to get cut off in the middle of this example, so I'll restart another video. If we have the function 4 sine x cosine y equals 1, if we take the derivative with respect to x, which is what we're used to, we're going to have to do a product rule. So u equals 4 sine x and v equals cosine y. Take the derivative of u with respect to x, so it's just 4 cosine x. This variable matches this one. These two variables match, so that's just a regular derivative. But this derivative, the x on the bottom does not match the variable we've got up here. So besides taking the derivative of cosine y, which is negative sine y, we have to put a dy dx on the end, or a y prime. All right, then we got our product rule. We've got u times v prime plus v times u prime. And remember to take the derivative of the right side, this one over here. All right, I'm gonna stop this recording and start another one.